Hi everyone. Today I'm going to discuss another factoring method, and this time we call it the sum or difference of two cubes. So when we say sum and difference of two cubes, we have to remember that we are dealing with either the operation addition or subtraction. And we are trying to factor binomials here. So when we say binomial, a binomial has two terms, and we will be dealing with perfect cube expression. So we call it the sum of two cubes or the difference of two cubes. So the left side is the polynomial that we are about to factor. This one is the sum of two cubes, while this one is the difference of two cubes. So how are we gonna work on the factors of each of these binomials? So first, we have to consider that the factors are composed of a binomial and a trinomial factor, such that this trinomial factor is dependent with this binomial factor. And this binomial factor is actually the cube root of both perfect cube expressions here. Likewise, this as well is the cube root of these perfect cube expressions. And then I was telling you that the trinomial factor is dependent with the binomial factor. This one is the square of A, while this one is the square of B. And the two here are the product of the two terms. And then we get the opposite sign, or we multiply the product by -1. So for us to use the formulas that I have presented in the previous slide, you must be able to recognize numbers which are perfect cube expressions. So for instance, we consider 1000 as a perfect cube since 1000 here equals 10 cubed. So an expression 10 is raised to the third power, and the result is a perfect cube expression. Likewise, 125 is a perfect cube expression since 125 equals 5 cubed, meaning 5 is raised to the third power. So with 64, 8, and 1 as perfect cube expressions. So to generalize, perfect cube expressions class are expressions um, which is the result of raising them to the third power. Now also, you have to note that these expressions are also perfect cube expressions. So if we have m to the 6 and to the 21st, we have a cube, b cube, c to the 6. And then if we include 64, h to the 6, j to the 12, these are also perfect cube expressions. So the exponent must be divisible by 3 for us to consider each of these as perfect cube expressions. Of course, we have to note that the coefficient of each of these expressions must be perfect cube as well. So you know that the result of raising an expression to the third power will lead us to a perfect cube expression. So considering the two will help us work on the factors on the sum or the difference of two perfect cube expressions. So 8x cubed minus 27 can be factored using the difference of two cubes. Now, if we will let a be equal to 2x and b equals 3, so we come up here with substituting the given to the formula here, and 2x will be the first term and 3 will be the third term. Now, another question that we have to answer is, how do we extract the cube root? Because this binomial factor is the cube root of the two given terms here, which are perfect cube expressions. For example, how do we extract the cube root of a cube as well as the cube root of b cube? So we just have to divide the exponent of the radicand by 3, and that's the cube root already. So when we divide 3 by 3, so that gives us 1. So cube root of a cube is a, while cube root of b cube is b. So likewise here, if we get the cube root of 8x cubed as well as the cube root of 27, so we know that the cube root of 8 is 2, since 2 to the third is 8. And we know that by simply dividing this exponent 3, so that is actually extracting the cube root of x cubed. So we have 2x here, and this is where we get this 2x. And we will let this as our a, as we follow the pattern here. And then we get the cube root of 27, and this is 3. So basically, the first thing for us to do in factoring, for example, here, the difference of two perfect cube expressions, we have to consider, or we have to work on the binomial factor first. And the binomial factor is the extracted cube root of the given two perfect cube expressions. So cube root of 8x cubed equals 2x, while cube root of 27 equals 3. And we separate them by a minus sign, since the operation of the given is subtraction. So we have 2x minus 3 here. And then this 4x squared was obtained as we square the first term, or a, in the formula. So we got 4x squared. And then 9 here was obtained as we square negative 3. So we get 9. And then the product of the two, 2x times negative 3. And then we multiply that by negative 1. So that's the middle term. So these are the complete factors. Now, if we check our factors, or if we multiply the factors using distributive property, so it's expected that we will come up with the correct given, which is 8x cubed minus 27. So if we do so, like we work on the distributive property, or we work on the product, special case on the product of binomial and trinomial, then we cancel similar terms. So we go back with the given here. Okay. Now, for another expression, x cubed plus 64, this can be factored as the sum of two cubes. So again, the factors on the sum of two cubes equals the binomial factor, which is the extracted cube root of a cube and b cube. And then the second factor again is the square of a, while the third term here is the square of b, and the product is, I mean, the middle term is the product of the two terms times negative 1. Now, if you are confused with this representation, what you just have to do is to come up with x plus 4 here as the binomial factor of this expression. We just have to extract the cube root of x cubed and cube root of 64. And then whatever the extracted cube root, so we have to separate them by an addition operation, since the operation of the given binomial is addition. So this is how we work on the first binomial factor. And then again, this trinomial factor was obtained as we square x here. So we got x squared as we square the second term of the first factor. So we got 16. And then the middle term here is the product of the two times negative 1. So we get negative 4x. One thing that you have to consider also, if this is addition, the middle term of the trinomial factor must be subtraction. So that's how we work on the factors of the second example. And then to verify as to our factors are correct, so we have to multiply the two factors, and the resulted expression must go back with the given x cubed plus 64. In that sense, so we'll come up with the correct factors. So how do we remember the formula? So we have to cube always. So cubes always factor into a binomial times a trinomial. And then the binomial in the factored version always contains the cube roots of the original expression or the given with the same sign that was used in the original expression. So we have made use of this pattern a cube plus b cube equals whatever the extracted cube root of a cube and b cube, and then we have to separate it by the same sign as to the given. So with a cube minus b cube, so what is the cube root of a cube? What is the cube root of b cube? So that's a and b respectively here. And we separate the extracted cube roots by whatsoever the sign of the given. And then we square the first term of the binomial factor. So there. And we find the product of both terms. We are referring to the binomial factor, and we have to change the sign. That's why I was telling you to multiply the product by -1. So we got negative AB, and we square the last term of the first factor. So it's B squared. So that's how we remember the pattern or the formula for this topic. Now, the difference of two cubes, class, equals a binomial times a trinomial, such that the binomial factor is the cube root of a and b with the same sign. So we get the cube root of a cube minus the cube root of b cube. And then the trinomial factor, we square the first term of the binomial factor a. So we have a squared. And then we find the product of both terms and change the sign. So this is a times b, and then this is actually a times negative b times -1. So we get ab, and then we square the last term. So we have b squared here. So cube numbers you will find in problems: 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, etc. Okay. So how do we work on the difference of 8x cubed minus 125? So as what I was saying, the factors is a combination of a binomial and a trinomial. So what we're going to do is extract the cube root of the first and the second term with the same sign. So this is the difference of two perfect cubes. So we got 2x minus 5. Okay, so cube root of 8x cubed equals 2x, while cube root of 125 equals 5. There. And then we're going to build now the trinomial factor with the binomial factor. So we'll work on the square of the first term, and that's 4x squared. And then we're going to find the product of both terms of this binomial factor, and we'll change the sign. So we have 10x, and then we square the last term. So we have 25. So those are the complete factors. Now for 64x cubed plus 1, so the factors are a binomial and a trinomial. Now the binomial factor is the cube root of 64x cubed and 1 respectively. So we got 4x and 1, and we made use of the addition operation, as the operation of the given expression is also addition. And then we square the first term of the binomial factor, and we got 16x squared. Then we work on the product of 4x and 1, and then we change the sign. So we get -4x. And then we square. We square the last term, which is 1 also. So these are the factors. So we come up with the factors of the left side. So what we're going to do here is to factor the following, working on the sum and two cubes, or working on the sum of two cubes or the difference of two cubes. So very obviously, this is working on the difference of two cubes. And we work on the binomial factor by working on the cube root of x cubed, so we get x, and the cube root of 27 is 3. So we consider the negative sign or subtraction since the operation of the given is subtraction. And we work on the trinomial factor by working on the square of x. So this is x squared. Working on the product of the 2 times negative 1. So this gives us 3x. And the square of negative 3, 9. So these are the factors. For number 2, binomial factor again is the extracted cube root of the two terms here. So cube root of 8x cubed is 2x, while cube root of 125 is 5. So we separate both terms by addition operation since the operation here is addition. And then the trinomial factor, first term is the square of 2x. So we have 4x squared. And then the middle term is the product of the 2 times negative 1. So we have negative 10x. And then we square the last term of the binomial factor. So we get 25. For this, we work on the cube root of 64. So this gives us 4 minus cube root of y cubed. So this is y. So square of 4 gives us 16. And then the product of the 2 times negative, I mean times negative 1. So we have plus 4y. And then the square of negative y gives us y squared. Here again, both terms are perfect cube expressions. So we have to extract the cube root of both terms. So we have x plus 10. So we separate the two by the addition operation since this is addition. And then the square of the first term of the trinomial, I mean the first term of the trinomial factor is the square of x here. And then the middle term is the product of the 2 times negative 1. So we have minus 10x. Then the last term is the square of 10 here. So these are the factors. So this is how we work on the factors on the sum or the difference of two perfect cube expressions. Now, I want you to work on the factors of each given here. And I'm encouraging you to write your answer in the comment box section of this lecture video. So I hope you're able to understand the discussion. Bye for now.